We talked about eliminating before when either the coefficients of x or the coefficients of y were either the same or opposites of each other. Now, we're going to have to make them opposites of each other. So, the very first step is going to be multiplying at least one of the equations by a constant to get two equations that contain opposite terms. Okay? So I look at this. Now, 5 and 10, they are not opposites of each other. Oops, sorry. And 5 and negative 3 are not opposites of each other. So you have to decide, are you going to be multiplying one of the equations or two of the equations by something in order to get the coefficients opposites of each other? Now, me personally, as I look at this, if I look at the 5 and the 10, I didn't mean to erase both of those things. I know that 5 goes into 10 two times. So if I wanted to make them opposites of each other, I could multiply the second equation by negative 2. Let's look at that. So if I was to multiply this whole thing by negative 2, I would then get negative 10x plus 6y equals 14. All I've done is multiplied the second equation by a negative 2. Now let's look at this. I have 10x and negative 10x. Now they are opposites of each other. So I'm actually going to write this. I'm going to change the color. I'm going to bring this and I'm going to bring it down here. So 10x plus 5y equals 30. And I'm going to add these two equations together. When I do that, I eliminate the x's because negative 10x plus 10x, that would get me 0. So now all I have is an 11y equals 44. And then I solve. When I solve this, y equals 4. So now I have my y value. I need to find my x value. Again, when you do this, I don't want that color. When you do this, plug it back into an original equation, just in case you've done something wrong. Plug it back into an original equation. So 10x plus 5 times 4 equals 30. So 10x plus 20 equals 30. Subtract 20 from both sides, and I get 10x equals 10. Divide by 10. X equals 1. So my point is 1, 4. Now I didn't show this on the other ones, but you can check and make sure that you have the right answer. Plug the 1 in for x and plug the 4 in for the y. So if I was to do that, to make sure that I have the right answer, look at that, 30 equals 30. So it worked for the first one. Now plug it in for the second one. So 5 times 1 minus 3 times 4, does that equal negative 7? So 5 minus 12, so negative 7 equals negative 7. So yeah, this is the correct answer. I would suggest checking your answers. You don't have to write it out necessarily, but I would plug it in to make sure that you do have the correct answer. Okay, on this one, if I first look at the 4 and the 13. 4 does not go into 13 evenly, and 13 doesn't go into 4 evenly. So that's not going to help us. Let's look at this. Ooh, 7 goes into 14 evenly. So I want to make the opposite. So the opposite of 14 is negative 14. So I'm going to multiply this by negative 2. So I get negative 8x minus 14y equals, 74? Negative 74. Now, these are opposites of each other. So we're good. So I'm going to take this and bring it down here. I have 13x plus 14y equals 59. I'm going to add these together. I get 5x. The y's disappear. Oh, and I need to subtract those, so that'll get me a 550. I divide by 5 on both sides, and I get x equals negative 3. Okay. Then I'm going to plug it back into one of the originals. I really don't want to multiply negative 3 times 13, so I'm going to pick the second equation. 4 times negative 3 plus 7, y equals 37. So negative 12 plus 7y equals 37. I'm going to add 12 to both sides. I get 7y equals, 49? I divide by 7 on both sides, and I get y equals 7. So my point is negative 3, 7. And that is my answer. Okay. Now if I look at these, does 3 go into 2? Does 2 go into 3? Nope. Oh, 3 doesn't go into 4, nor does 4 go into 3. So we need to multiply both of the equations by something. Does it matter? No, it doesn't matter. Now, I'm going to pick getting rid of the x's. Why am I going to do that? Because one of them's positive and one of them's negative. So, just like when you were finding common denominators, we're going to find a common coefficient. And guys, the easiest way to do that is multiplying this by the 2. That 2 right there, multiplying that by the 2. And multiplying this by the 3. Now, why am I not multiplying by a negative 2? Because the whole point is so that I can get the coefficients opposites of each other. So I want one of them to be positive and I want the other one to be negative. So if I multiply by 2, I would get 6x plus 8y equals negative 44. Okay, this next one, I get negative 6x plus 9y equals negative 24. Now, could I have multiplied the top one by 3 and the bottom one by negative 4 or negative 3 and 4? Yes, to get rid of the y's. Does it matter? Absolutely not. The only reason that I did 2 and 3 is because they already have an opposite sign. Okay, so this will get me 17y, negative 68. Is that right? Yeah. Divide by 17. And y is going to equal negative 4. So again, when I'm plugging this back in, I'm plugging it back into an original equation. Which one I'm just going to pick the top one on this one because multiplying by 3 or 4, they're both not that hard. So I'm going to take y and I'm going to replace it with negative 4. So I get 3x minus 16 equals negative 22. Add 16 to both sides. Add 16. And I get 3x equals negative 6. I divide by 3, and x equals negative 2. So my point is negative 2, negative 4. Okay. On this one, I'm going to do the y's just because, yes, they have opposite signs, but I also want to show you that if I look at these two numbers right here, do I have to multiply, sorry, do I have to multiply by 6 and 9? No, I don't. What is something that 9 and 16 both go into? They both go into 18. So I could just multiply these so that they both become 8. One becomes 18 and the other one becomes negative 18. So I'm going to multiply this first one by 3. And when I get that, I get 33x minus 18y equals 75. Oh, no, I don't want that color. And if I multiply this one by 2, I get 9. Oh, no, I do not. I get 6y. I get 6x plus 18y equals 120. Now, could I have multiplied the first one by 9 and the second one by 6? Sure. So sorry, guys. So 39x equals 195. I divide by 39. X equals, I have no idea. Where is my calculator? I actually could probably figure that out. Oh, easy peasy, 5. Now, does it matter which one I plug it back into? Absolutely not. Which one am I going to do? I don't know, just the first one, I guess. 11 times 5 minus 6y equals 25. I get 55 minus 6y equals 25. Subtract 55. I get negative 30. I divide by negative 6. And I get y equals 5. So that's the 0.55. Okay. And again, plug it back in. Make sure you have the right number. Okay. Down here we have Jorge's comic book collection consists of single issues that cost $4 each and paperback collections that cost $12 each. He has 100 books in all. His collection cost him $616. Write and solve in a system of linear equations to determine how many single issues and how many paperback issues Jorge has in his collection. Well, what are the two things? We have single issues, we have paperback books. So, let X equal the number of single issues. Now, how did I know that that's what I was looking for? Well, isn't that what it's asking? It says, write and solve a linear system of equations to determine how many single issues. So I know that one of my variables needs to be single issues. Does it matter if it's X or Y? No, but you need to tell us which one is going to be X and which one's going to be Y. And Y is going to equal the number of paperback books. That was weird. I don't know. Now, to write this, What it's talking about is it's talking about money. So one of the equations has to be talking about money. The other one says that he sold 100 books. So this is going to be talking about the number of books. Oops, I should have done a different color on that. Let's do green on that one. So if I'm talking about money, it tells me a single issue costs $4. So 4x. Now, how did I know that was multiplication? Well, if one book costs $4, two books cost $8, three books cost $12, how do I find that? I take $4 and I multiply it by the number of books that I have. Plus, it costs $12 for a paperback. Now, where does it say how much the total amount is? Right here it tells us the total amount. So it's $616. So that's our first equation, and it has to do with money. Now, our second equation deals with the number of them. Do we know how many paperbacks we have? Do we know how many single issues? No, that's what we're trying to find. So I know the number of paperback book, or the number of single issues, plus the number of paperback books. I know when I add them together, then I'm going to come out to 100. But I don't know how much each of them are. So there we have it. We have a system of equations, and now we need to solve this. So, with this system, we need to either get rid of the x's or we need to get rid of the y's. Now, me personally, I personally would get rid of the x's because I would rather multiply by a -4 than a -12. But you can do whichever one you want. Doesn't matter. So I'm going to multiply this by -4. I'm going to get -4x minus 4y equals -400. And then I'm going to take the original equation up top and I'm going to put it right here. So 4x plus 4y equals 616. When I do that, I get 8y equals, and that's going to be 216. Did I do that right? I'm going to divide by 8, and y is going to be, that's going to go in 2 times, I think that's 27. But let's make sure before I, again, yep, 27. Okay, so now I take my y value and I plug it back into my equation. I'm going to plug it into the second equation. Why? Because it's the easiest one to do. I'm going to subtract 27. And I'm going to get x is equal to 73. And this is a word problem, so you can't just say x is 63 and y is 27. No. What do these numbers stand for? So x stood for single issues. There are 73 single issues and 27 paperback. Okay, so let's do this again. Okay, one last problem. So a software company releases 2 products. Oh, they're already telling us that there are 2 products. A home version of their photo editor, which costs $20, and a professional version, which costs $45. So it's already telling us our 2 items. So the 2 things that we're dealing with are a home version of photo editor and a professional version. The company still sells 1,000 copies of the photo editing software. earning a total revenue of $38,075. Write and solve a system of equations determining how many home versions and how many professional versions. Okay, so let's do this. We're going to let x equal the number of home versions and green. Let y equal the number of professional. Really? I just put two F's in that for some reason. Okay. So now, let's see. So we have the money amount and we have the number of. So how much does a home version cost? Home version costs $20. How much does a professional cost? $45. What is their total amount of money they have? $38,075. Now, do we know how many home versions? No, we just put X. Know how many professional? No, but we know together that they have 1,000 copies. Okay. So when we do this problem, I personally would multiply by 20 rather than multiplying by 45, but that's just me. So I'm going to multiply by negative 20. So I would get negative 20 minus 20, negative 20x minus 20y equals negative 20,000. And then bring my original equation from up above. Okay. I'm going to add these up. And the x's go away, and I get 25y equals 57081. And yes, I probably could do this in my head, but we are not going to do that. 0.75 divided by 25. So y equals 723. I'm going to plug that back in. So x plus 723 equals 1,000. Subtract 723. And that's going to get me x equals, that's a 7, that's a 7, that's a 2. There are 277 home versions and 723 professional versions sold.